Hi, I am Lakshmi, Department of Mathematics, SNS College of Technology. Today we are going to discuss about transformation to principal axis, a conic section, and find out the what type of conic section the following quadratic form represents. So the quadratic form and the corresponding value is also given. So the value, that is the first sum value is 128 and second sum value is 0 and third sum value is 70. So quadratic forms we want to calculate. For this calculation we move on to the sum. First thing we want to calculate, for already we discussed earlier, from this quadratic form to diagonalized matrix. So diagonalized matrix means first thing we choose the matrix and then for the characteristic equation C1 and C2 is needed. If we write the equation and we get the lambda values. Lambda here, the lambda values are uh, 32 and 2. For this 32 and 2, we can calculate the corresponding eigenvector. So the corresponding eigenvector for the corresponding values of first for the case 1 we are choosing lambda equal to 32. So for this 32 we got the values as x1 equal to 1 and minus 1. Next we can choose lambda equal to 2. So lambda equal to 2, the second value, if we choose the second value and we got the corresponding x2 value is 1 1. So easily we got, already we discussed many times calculating the eigenvalues and eigenvectors. So I am closing up to this. So next, based on this, the model matrix we are calculating. So for x1 value and x2 value, we can write from this, the normalized matrix we can calculate easily. So in this model matrix, then from the model, using the model matrix we can write the normalized matrix. So 1 and minus 1 only it is given. So first row and second row, whatever it is, we got the value as root 2. So 1 divided by root 2 minus 1 by root 2 plus 1 by root 2 plus 1 by root 2. So here the value we can choose the 1 by root 2 as a common term. So the remaining matrix is 1 minus 1 1 1. So for this matrix we can write n transpose. So once you know the matrix, if you know the matrix n and n transpose, directly we can move on to the calculating the diagonalized matrix. So I am writing the diagonalized n transpose an is the formula for to calculating the diagonalized matrix, n transpose value and then a value and then n value. So if you multiply first matrix, second matrix, third matrix together, we get the diagonalized matrix. So 32 2, these alone will get, the remaining values are 0. So once you got the value, we can write the canonical form. So canonical form we are writing from this diagonalized matrix. So here we check it. The diagonalized matrix is y1 y2, the row matrix, and then the D matrix and then Y matrix. Multiplying these three together we get the 32 y1 square plus 2 y2 square, and then at last the canonical form is derived. After this you can calculate the conic section for this sum. So given in the given sum, quadratic form is, value of this quadratic form is given 128. So at last this corresponding quadratic form value is, we got it as 32 y1 square plus 2 y2 square. So we can comparing these two values, we easily get. So take this 128 to the denominator. So 32 and 128 we got the y1 square divided by 48 and 2 divided by 128 is y2 square divided by 64. Got this equation. So from this equation it is a if we write these two terms as a simplified term, means y1 square divided by 2 square plus y2 square divided by 8 square, so which is equal to 1, which represents the ellipse of this. So this way we can easily calculate the conic section. Likewise the second, for the second sum and third sum also we can write. At last we got the quadratic form, the final answer is 0 is given. So here we in this 14 y1 square minus 8 y2 square is the given value we got from this equation. So which is equal to 0. It represents the pair of straight lines. And then for the third sum, q value is given, that is 70 is given. So the corresponding value y7 y1 square minus 5 y2 square. So it is a hyperbolic equation. So this way easily we can calculate the terms which is given.